Once I learned this method for finding and evaluating trig functions, I've never looked back. I actually think this is the easiest way to do it. And it's just a hand trick for evaluating trig functions. So we're going to pretend that our left hand, if you look at your left hand, it's going to look like the hand that I have on the board. Thumb's pointing up and pinky is pointing to the right. And imagine this being the first quadrant in a unit circle, which means this is 0, your thumb is 90 or pi over 2, and then your ring finger would be 30 degrees or pi over 6. Your middle finger would be 45 degrees or pi over 4. And your pointer finger would be 60 degrees or pi over 3. So the question that you have to ask yourself or know is, what's your reference angle? And if your reference angle is pi over 6, pi over 4, or pi over 3, you're going to fold down that finger. And when you fold down that finger, you now have a split set of fingers. So let's just use an example. So if I have the sine of pi over 3, if I have pi over 3 as my reference angle, then my pointer finger is going to be folded down. Since I can't do that on a board like this, I'm going to highlight it. And when you think of pi over 3 folded down, your pointer finger not there anymore, you have this set of fingers, which is actually only 1, and then you have this set of fingers, which is going to be 3. If you think about your unit circle, and when you evaluate sine and cosine for pi over 6, pi over 4, and pi over 3, all of them are divided, have a fraction over 2. Every single one of them. And technically, all of them have a square root in the numerator. 1/2, while it's not written, is the square of 1 is the square root of 1. So they all have a square root in the numerator. So our entire problem with this is going to be based off the square root of a number over 2. If I am asking you to find the sine of pi over 3, we fold down this pi over 3 reference angle, and the fingers that I have remaining on the top represent your cosine of the angle, and the fingers that you have on the bottom represent the sine of your angle. So since I am asking to find the sine of pi over 3 is folded down, so I should have 1, 2, 3 fingers left over. So I'm going to come over here, and in my square root, I'm going to write 3. So the sine of pi over 3 is the square root of 3 over 2. I also know then right away that the cosine of pi over 3 is, I have 1 figure left over here, so I would have the square root of 1 over 2, which happens to just become 1/2. So let's try another. Let's not have pi over 3 be our reference triangle or angle. So there's my finger. Let's do the cosine of pi over 4. If I think of pi over 4, I'm going to want to fold down pi over 4, which is going to be your middle finger. So then I look at how many fingers are above. Now I'm going to have 2 of them. How many fingers are below? I'm going to have 2 of them. So if I'm asking to find the cosine of pi over 4, I look at the numbers that are on the top are going to be cosine. So there's 2 fingers. So I am going to have the square root of 2 over 2. You can also find tangent on this as well. Let's do tangent of pi over 6. Tangent is y over x. It's opposite over adjacent. So tangent ends up being sine over cosine. So if I want tangent of pi over 6, let's erase some of this stuff. If I want tangent of pi over 6 is going to be my reference triangle, my finger that I'm going to fold down. So the sine of pi over 6, there's only one finger left over in the sine region. So the sine of pi over 6 is 1 over 2. And the cosine of pi over 6 is going to be the square root of 3 over 2. And if I simplify that, I get 1 over the square root of 3, or the square root of 3 over 3. So you can use it for tangent as well, as long as you know that tangent is sine over cosine.